morning. Good morning, students. Welcome in Unit 1 Crystal Structure. This Unit 1 is for B.Sc Physics TY students. Paper number 13A. Name is Solid State Physics. So welcome in Sanjeevanee Mahavidyalaya Chapoli, run by Navivak Shikshan Prasarak Mandal Chapoli. Our college is affiliated to Swami Ramananda Tirth Marathwada University, Nanded. Again, I welcome in the Department of Physics. Here we discuss crystal structure. You are familiar with the solids. Solid means what? Its properties means what? How solid we define. All these things you are well known. You might have studied in previous standards. So we discuss about its crystal now in exact nature of the crystal. Solid is nothing but a regular and repeating pattern of constituent particles in which each particle is representing a point. What we are considering a point. So a regular 3D, three-dimensional arrangement of points in space is called as what? Crystal structure. I'll show you figures so that you will come to know the idea of regular arrangement of 3D, three-dimensional figure. So remember, regular 3D arrangement of points in space is called as what? Crystal structure. You see now, carefully this figure. Suppose these are the various constituents of the solid. We consider that each constituent of in the solid like this red, green, these constituents we consider as what point. I mean they represent, they depict, I mean these are depicted by the points in the solid. These particles are depicted by points. So here red, green, red, red, green, red, red, green, red. What is this? A regular and repeating arrangement of the points in the space. So a lattice is nothing but, in general we define a discrete but infinite arrangement of infinite regular arrangement of points in a vector space. So in this way easily you can define a lattice in solid. Now let us turn towards the next concept, that is unit cell. What is unit cell? Simple example I will tell you. Suppose you have a wall. You know, wall. Wall is constructed using what? Either bricks or stones. Isn't it? So you take a brick, and these bricks, what happens? We expand in both directions, in all directions, to form a wall, to construct a wall. So the smallest unit of the wall, and I mean wall is made up of the smallest unit, that is said to be brick. Likewise, in our solid state, in crystal structure, we have to carefully remember that unit cell is nothing but a smallest portion of crystal lattice, which when repeated in different directions generates the entire lattice. So what is unit cell? Unit cell is the smallest portion of crystal lattice, which when repeated in different directions generates the entire lattice. You see, this is the what? Unit cell. It has three axes we have taken, X, Y and Z. Unit cell is said to be building block of a lattice. In a construction of wall, building block is brick. Likewise, unit cell is building block of lattice. One can say unit cell is a small unit of lattice. It is a small unit of lattice. Normally, you consider or you try to understand with the help of example of wall and brick. So brick is nothing but what? Small unit of your wall. Likewise, unit cell is nothing but small unit of a lattice. Here it is shown in figure lattice. Now let us turn towards the various characteristics of lattice. I mean characteristics of unit cell. What are the characteristics of unit cells? First point you remember, here it is shown, x-axis is shown by vector A, here y-axis above it is shown by vector B, and z-axis is shown by vector C in figure, carefully observe. The angle between x-axis and y-axis is shown by a letter y, and z is also shown by alpha, x and z beta, and this is what? Gamma. Once you observe figure, then you will come to know easily. Now let us turn toward the various characteristics. First one is what? Its dimensions along three edges are A, B, C. Small a, small b, small c. Three edges may or may not be mutually perpendicular to each other. Got it? The three edges may or may not be mutually perpendicular to each other in the sense the angles between them may or may not be equal to 90 degree. Now let us turn third. Angles between their edges be alpha, beta and gamma. Alpha here shown between y and z, beta z and x-axis, gamma y and x-axis. In next slide I want to tell you, I will show you a unit cell. Next characteristic is what? A unit cell is characterized by total 6 parameters. How many parameters? 6 parameters. So like brick has what? Length, breadth and height, 3 parameters. So like a unit cell is characterized by 6 parameters, that is A, B, C, and angular parameters alpha, beta and gamma. In this way 6 parameters A, B, C, alpha, beta and gamma you remember. Now let us turn towards the parameters again in details. A unit cell is repeating in all directions. Are you agree? Unit cell is repeating in all directions to cover some areas also. It covers some areas also. It is considered to be extended in all directions. So it covers some area. What is this area? Suppose this comes from this to this, this to this, this to this, like this. Here, a centimeter, for example, a centimeter length covers along x-axis. B centimeter covers, length covers along y-axis. And next parameter is what? C centimeter length covers along z-axis. It is to be considered extend in all these 3 axes. Now what about the angular parameters? Angles between the edges. Already I have told you. The angles between these three axes are alpha, beta and gamma. The angle between x and y axis, between the axis x and y, is suppose alpha, y and z beta, and x and z again gamma. So in this way there are three edges and three angles. I mean parameters are related to three edges and three angles. In all, how many parameters are there? 6 parameters are there. What are those? Three edges A, B, C, and three angles alpha, beta and gamma. Now what are the characteristics of categories of unit cell? Types of unit cell. Basically there are only two types of unit cells. They are two types. Number one, primitive unit cell P, and second one is centered unit cell. Now question arises, what is meant by centered unit cell? What is meant by primitive cells? Is there any other types again of primitive, again of centered unit cells? So primitive cells means nothing but we can say that primitive cells is nothing but what? We can say that this is a simple cell in which points and coordinates are present. It is a simple. But we take more interest in what? Centered unit cells. So in centered unit cells again it has three types. Basically two unit cells, primitive and centered. Primitive means simple cell, and centered unit cells again has, I mean it includes three types. What are those? These three types are lines. What we say to this first one? Number one, body centered unit cells. BCC we can say, body centered unit cells. Next type of centered unit cell is what? Face centered unit cell. What is this? Face centered unit cell, FCC. And next one is end centered unit cell, A, B or C. So these are the various types of centered unit cells. You usually can remember BCC, body centered unit cells, FCC, face centered unit cells, and end centered unit cells. What about the body centered unit cells? What about face centered unit cells, end centered unit cells? All these cells types of cells of centered unit cells we are going to discuss in next lecture in detail. So remember only now what is lattice, what are the types of lattice, categories, primitive and centered. In the three again in centered lattice, remember BCC, FCC and end centered unit cells. So this much you remember in this lecture. In next lecture we discuss in details about BCC, FCC and ECC. Thank you.